Sustainability is a tough topic because it just means so much to every single person. So to me, I'd say it's really all about efficiencies. It's doing things the right way to make sure what you're creating and putting out into the world is not something that's going to come back around 10 years from now as a problem.
Our recycling industry is more than what we place on the curb for pickup. There are so many facets, and we've talked about a few of them on our podcast. Today, we'll talk about expanding the ability to be recycled and putting technology into more people's hands. To tell us about how this area is advancing, I'm joined by a brilliant chemist and inventor, Brian Schmatz from BASF's subsidiary TrinamiX. Brian, thanks for being here today. We're here to talk about something you've been working on for quite a while, expanding the ability to be recycled and putting technology into more people's hands, and about how this area is advancing.
Yeah, so I worked on an innovative new technology called a mobile near-infrared spectrometer.
A mobile new infrared spectrometer.
Yes, so near-infrared spectroscopy is a really common technique used in a lot of research labs, but also used for quality control in the food and agricultural industry.
And what that is?
It's similar to our human vision, visible spectroscopy. And what that means is when we perceive colors, what we're really seeing is the light bouncing off those materials, and every material will absorb and reflect light a little bit differently. These plants here look green because they're reflecting green light at us, whereas something like this chair that's wooden is reflecting more of a yellowy light. So we use this on a day-to-day basis to make decisions. Example, going to a grocery store and picking out some bananas. You see yellow, green, brown, and you know the yellow bananas is the one you want to buy.
Okay, so what role does this play in recycling?
So that's using visible spectroscopy with our eyes to make decisions. So when we go into near-infrared spectroscopy, you're looking at much more chemical compositional properties. So how much sugar there is in an apple, or how much moisture there is in soybean meal, or what type of material is that plastic made out of. So since we can't see near-infrared light, we need to use sensors, a near-infrared spectrometer, and we are one of the first companies to bring this into the world as a handheld device.
So for my mom, what does this device do?
Your mom can scan a piece of plastic and it will tell you whether it's PET or HDPE or LDPE.
How's that helping?
For sortation purposes. You need to separate them to be able to give them a second life. A lot of people are familiar with the recycling codes on plastic. So if you look at most materials that you're buying from the store, again, water bottle and things like that, there's usually a 1 through 7 code. And that's telling you what that material is. So number 1, 2, 3, 4, those are all different types of polymers. And different polymers can't be mixed together.
So a 1 can't be mixed with a 3.
Exactly. Yeah. If you took those two and tried to, chop them down, melt them together, it wouldn't be structurally sound. They'll want to separate. And so that can lead to mechanical issues, discoloration issues, just a lot of issues that people don't want in a product. And when you're already trying to use of recycled materials, you don't want to add lower functionality. So from a chemistry level, there's a strong need to separate those materials.
So who else is using it? What kind of things are they recycling?
So a good example is textile recycling. There's a lot of criticisms around things like fast fashion where people buy clothes, throw them out, and they just kind of go into the trash and landfill. So more and more people are looking to see how we can recycle them. But again, to do that, sortation is a big first step. And so we sell to people who are sorting these types of waste streams. So think of the boxes around many cities that are collecting old clothing.
I saw a bunch out there, yeah.
So you can empty one of those and use a device like this to sort out what you're looking at. So I can just go into my app here. We've got a textile specific use case.
Oh.
So I can click textiles. I can then just put this onto my pants, for instance, click the button for a scan, and it will tell me this is a wool polyester blend. I can go to my shirt here.
Wow.
And see that this is cotton, and let's see what my coat is as well. And my coat is also cotton. So you can see just in a couple of seconds, I was able to identify 3 different pieces of textiles that I'm wearing by being able to separate wool from cotton from polyester. you can now sell those 3 separate waste streams to be repurposed for a new life.
So they can use this to quickly identify, okay, this goes with this kind of plastic, and be able to more easily identify, separate, and recycle.
There's a lot of others, and we're always learning new ones. Fishing net recyclings.
I've heard there's fishing net out there in our waterways, right?
Yeah, nets can be very expensive to landfills, so they often just keep them on the dock. And unfortunately, sometimes these can make their way from the docks into the waters. But as I mentioned, they can actually be very valuable waste streams because those materials are very robust and can be put back into engineering applications. They can find new life in a car that will exist for another 20 to 50 years.
Yeah. How'd you get into this?
Yeah, so I got my PhD in polymer chemistry. When I started, I worked on a pigments team for a while, and I had heard of TrinamiX. So I put my name out there and said, I really want to be part of this. They took a chance on me, and I've been here for 4 years.
When you got your PhD and you went into this program, it was like a 5-year intensive kind of training program?
Yeah, it's called the Leadership Development Program.
So in that 5-year program, were you able to come up with some new ideas?
Yeah, definitely. Something I really enjoyed doing was within our pigments division, making colorful sparkle pigments. And I remember talking about this with a friend, and they said, this actually is an area that's really ripe for sustainability. If you think about it, making a slight tweak that can make a product more sustainable can have such a big impact. So I looked into experimenting a bit in the lab and actually came up with a way to make a bio-based glitter that would then be made from renewable sources, but also then be biodegradable at its end of life.
That's amazing. And it's an innovation that I want to come to the market. I think we all do. How'd you get into chemistry? Like, who were your role models and what did you learn from them?
Yeah, I would say definitely one of my biggest role models is my dad, who was in infectious disease research. So he used to take me to New Jersey, the Liberty Science Center, and we used to always go for the new exhibits. So I think I was just exposed to science a lot at a young age. And then when I was in high school, chemistry really just clicked with me and followed my passion from there.
That's awesome. You actually are an inventor. There's got to be a lot of trial and error. What do you learn from that experience?
Yeah, it's failing fast. That's commonly said term within startup communities. Going out there, working with the people who you want to be using your technology. And before you spend too much time, hear their questions and then go back and start reinventing or modifying and then going back and doing that again. If you spend 2 years trying to build something and then you go out and find out no one wants it, the 2 years is wasted.
That's a great lesson. Let's talk about sustainability. Like, what does that mean to you?
To me, I'd say it's really all about efficiencies. It's doing things the right way and thinking through processes, thinking through products very strongly at the outset to make sure what you're creating and putting out into the world is not something that's going to come back around 10 years from now as a problem. It's about really thinking through everything you do strategically and making sure you're working as efficient as possible. And that can be, working at a plant and finding ways to reduce energy usage or reduce water usage, or, just in your day-to-day at home, figuring out how can I reduce the amount of waste that I'm creating.
I'd love to hear from your perspective. What are some common misperceptions around plastic?
Yeah, I'd say the biggest one is saying that recycling is not real. It does have a lot of challenges to it, but if there isn't that trust and buy-in to take your recycled materials and put them in a blue bin, the system can never work. There are a lot of innovations coming to make plastics recycling more efficient, but we need people to be ready for that moment to keep recycling, keep supporting the system. Recycling is indeed real.
That's good. You're right about the trust. It's really important.
I like to talk about design for sortability as well. So you can think designing for recycling could just be I'm using a material that is recyclable. I'm making bottles out of HDPE that is recyclable, and it also has an end market.
That means someone will buy it because it's worth enough for them to want to use it.
Yes, that plastic bottle is very recyclable, but if it's getting pulled into the metal waste stream, it just ends up as a contaminant and won't be recycled. So while that package is theoretically recyclable, if it's not being sorted correctly, it's not really getting recycled.
That's really helpful how you explained it. Are there other elements that you encounter that make something designed better to be recycled or sorted and recycled?
Yeah, so a big one that really shocked me is black plastics. The issue with carbon black pigmented plastics is they cannot be sorted by the types of equipment used at recyclers. Carbon black is black because it absorbs all visible light. So that means every light that hits it is going into the material. So when we shoot this near infrared light at it, it acts as a sponge and it takes all of that light in and nothing is given back as data. All that our system is seeing is something that's black, but I can't tell what material is underneath it. So that's commonly why black plastics, while theoretically recyclable, it's just going to make its way to a landfill.
So how are you helping with that issue?
So when I mentioned there's an issue with black plastics, it's not really the color black, it's specifically that pigment carbon black. So we worked closely with a lot of industry stakeholders, including the Association of Plastics Recyclers, and we did a study with a lot of different black plastics. Through that, we were able to write a design guideline with the APR, and that lets a packaging designer test a piece of plastic and know whether or not it will be sortable in an industrial facility. So now we've got packaging designers using our device to simulate an industrial environment right in the lab. So that way, if they're formulating a new package, they can test it, see if it passes the guideline. If not, they go back to the drawing board, reformulate, and try again. This has made their process a lot faster and a lot less expensive as well.
Wow. Brian, thank you so much for being on the show today. We loved having you, and I'm sure our listeners loved it as well. Listeners, let us know what you want to talk about. We'd love to hear from you, as always. I look forward to sustainably speaking with you soon. See you next time.